Alrighty, it is Friday, which means it's time to do the weekly studio review. This time we're doing Studio 1, the first, the first quote-unquote real studio. This one counts. Unfortunately, as some of you may have noticed, I was unable to attend this week. My daughter, I'm afraid to say, has tested positive for COVID, so I have been home with her the last few days. I hope to return back to campus early next week. But that's not going to stop me from going through and doing this studio review for you. So I've already got the code loaded up into Eclipse. My good friend Franklin is here this week. Say hi to everybody, Franklin. Me and Franklin go way back. He's an old man. He's about 14 years old, but he's a good friend. All right, let's go ahead and hop into the studio. Got the code loaded up. The first problem is called Hi1. We're going to locate that file in just a moment. It says say hello to the name. Supplied as input to this program. So if we go over here and we open up this file, we can take a look. Just kind of reviewing the code that's already here, you can see that the scanner is being created for you. Then there's a message that says enter a value for arg0. That's maybe a little bit of a confusing message, right? Especially for those of us who aren't used to talking in computer science jargon. So, you might say something a little bit nicer here if you wanted to. Enter your name or something like that. And then you see on the following line, we see that we create a variable. So the variable's type is going to be a string. The name of that variable is going to be name. And then we're going to retrieve that variable from whatever the user decides to type in. So our task is to say hello to whatever value the user types in and enters into this name. So, if we wanted to, we could just print out that variable directly, and that's fine, right? So if I just say system.out.println name, and then I run this program, we can take a peek and see how it works. Enter your name. I'll use Franklin, since my buddy Franklin is sitting right here, and it just says Franklin back in return. But we want something a little bit more than that. We want to say hi, how are you, or something, something along those lines. There's more than one way that you can do this. You might consider that, okay, I could actually do multiple print statements here as one way. So I could say, hi. Oops, don't need to yell. All right. Hi followed by name, right? And notice that on this one I use print versus println, the difference being that print does not move me down to the next line, whereas println prints out the thing and then moves me down to the next line. So that's how I keep moving the text down the screen. So this should be on the same line as this. Let's try it out. All right, Franklin. Now it says, hi, Franklin. That's good. I want to show you another way that we could have done this, though, using a technique called concatenation. So using string concatenation, it looks a lot like doing addition, using the plus sign. However, data types are what's really important when it comes to determining how operations are going to work. So the fact that I'm using a string here indicates that this plus sign is not going to be doing addition, not going to be adding things together. Rather, it's going to be doing string concatenation, which takes whatever value is in this variable and just tacks it on the end of this string and treats it as one whole unit, one single unit. So we no longer need to do this since we've concatenated that value onto the front of what we want. In fact, we could even go a step farther and concatenate more stuff on the back. So we could say, how are you? Notice I used another plus sign, right? So hi, plus sign, then a variable, plus sign, and then another string after it is going to stitch that, whatever that variable is, in between these two pieces of text. Let's go ahead and try it out. All right, I'll say hi to Franklin one final time. Hi, Franklin, how are you? He seems to be doing pretty well. He's very curious about what I'm up to, huh, bud? All right, I think that takes care of that problem. Let's go ahead and take a peek at the next one. We're going to expand our hospitality and do 4 names this time. All right, so as you can see an example, they want us to use proper punctuation. Here we go. Oops, that's not what I wanted to do. Sorry about that. I'm going to switch over to Eclipse. There. All right. So here you can see, taking a look at the code that we create the scanner, and then we ask for 4 values, 0, 1, 2, and 3. It might seem a little odd that we count from 0, but that's actually a very typical thing that we do in computer science. We'll start to see that pop up a lot. We've created variables called S0, S1, S2, and S3. Not the best variable names, but I suppose they'll do for this simple exercise. And now we want to say hello to all of the names, making sure to do proper punctuation. You could, again, do this in multiple ways if you wanted to. You could do, many print statements, one after the other. I've seen people do it that way in the past. I actually think, though, that getting used to concatenation is a good idea. So I'm going to try and do it all as one statement, one single print line, using concatenation. So S0 is my first one. Oh, actually, I need to say a greeting first, right? Hello. And then, do I need a comma here? English is not my best subject. And then I'll start concatenating these on here. I need a comma in between each one. So I'll say plus, and then put a comma, and then plus, and then another name, S1, and then another comma. I'm not typed today. All right, here we go. I'm going to blame Franklin. No, I'm not. It's not his fault. It's mine. S2, another comma, and then S3, semicolon. All right. So then if we run this and we do something like Leo, Mike, Raphael, and Don, for our 4 names, it says, hello, Leo, Mike, Raphael, and Don. It's stitched them all together with commas in between. I think that's probably, the most concise way of solving this problem. I do want to reiterate, though, that that's not the only way. If you decided to use multiple print statements here to break this up into different pieces, I don't think that you should feel, like that's a wrong solution in any way. Sort of a recurring theme in computer science. There's always going to be more than one way to do something. So the correct way to do it in most circumstances is whatever way, makes the most sense to you. There are other things worth considering as well, but, for now, just doing it whatever way makes most sense to you is probably the best way to go about it. So if you found another solution, fantastic. I'm going to go ahead and move on to the next problem here. Now we're looking at... oh, yes, I'm sorry. Before I do that, let's do this quick conceptual checkpoint. So just want to make sure that we are understanding what we're actually taking a look at here. One question we asked you to chat with your TA about are what the class and the main method refer to. So you can see that every single file in Java has a class and a main method up here. I mentioned this in the review video, that for now we can kind of treat these as a sort of magic words that every program needs to get up and running. A little bit later on in the class, we'll see exactly what we mean by a main method, and then a little bit after that, we'll start seeing what exactly we mean by a class. But for now, you can just kind of treat these as the magic words that we need for our program to do things, to do the things that we tell it to do. All right, back to the next task. We're looking at ordered. So now we want to define a Boolean variable, is ordered, whose values is true if the 3 values are strictly ascending or descending order. So if they're all going up or down, we want it to be true. But if they're out of order, then we want it to be false. And then we'll just print out the results. A quick clarification here for those of you who may have seen an if statement before. We're going to introduce those pretty quickly here, but we haven't seen them yet, and you don't need an if statement. But you do need a little tool here that I'll talk about a little bit later on. Let's open up the file and see how far we can get, for starters. So here's our scanner. This time we're asking for integers, so pay attention. You can see that it says in.nextInt here instead of next line. That's important. All right, so we want to create a Boolean variable. That was our first task. So the way that we create a variable, First, we have to specify what the type of that variable is. We can see that up here with these integer variables that are being declared for x, y, and z. So if I want to create a Boolean variable, I'll specify that the type is going to be Boolean. That means that the only value it can really have is true or false. That's a very important thing to keep in mind. The next thing that we're going to do is give it a name. So I'll call it isOrdered. I believe that's what the instructions told us to do. And now we can put the equal sign in there, and whatever comes to the right of the equal sign is going to be the value of isOrdered. And so we really want to check to see if these are in order or not. And so one of the things that I see people trying a lot is maybe something like this. X greater than y greater than z. Logically, this makes sense, right? As humans, we look at this and kind of understand what we're trying to go for here. In fact, it looks very similar to what we saw in the instructions, as a matter of fact. But consider that for computers need things in a very particular way. Specifically, if we look at this right here, which is what we would call a relational operator. Okay, this is a greater than sign. This only operates on two things. So this is going to look at x and y and say that's either going to be true or false. Either x is greater than y or it isn't. So it'll be true or false. And then it's going to give back that value for that expression. And then it's going to try to evaluate what's left. And so this is going to be either true or false. So we have to think about that. It's going to be true is greater than z or false is greater than z. And that doesn't really make sense. That's not really something that can be computed. In fact, what we really mean to say is that, x is greater than y and y is greater than z. That's really a more explicit form of what we're actually trying to compute here. And that's what the computer wants. That's what the computer wants to see. The computer wants to see a statement that's more like that says x is greater than y and y is greater than z. So you need a new tool to do this. I know we kind of threw a curveball at you. This was something that was not explicitly laid out in this week's prep work. In fact, it'll be in next week's prep work. But that's part of programming. I don't feel too guilty about this because learning new things, being expected to learn new things as you work on a problem is part of programming. That's a very common thing that programmers are tasked with doing. So we introduced these two new tools to you. I know a lot of you spoke to your TAs about this, or maybe some of you are already aware of these tools and were able to explain it to your group mates. Either way, you definitely will see these again in the prep work for next week. But for now, you can see that these two ampersands represent and. So if I have a true on one side and a true on the other side, that's going to give me true. So if both things are true, then that means that I'll get true back. But if one of the things is false, either the left side or the right side is false, then that means I'll get false back. And then we also have or. So or is similar to and, but kind of the opposite. As long as one or the other thing is true, then or will give us true. And that means that if both things are true, so here I can see that true or true and false or true are both going to give us true. But false or false makes false. This symbol, by the way, this little symbol that you see here is what we would call a pipe, and the key for it is directly above your enter key on the keyboard. So if we want to kind of rephrase what's going on here, we can say that this is going to be x is greater than y and y is greater than z. This is a way that the computer is going to recognize, right, for what we were trying to accomplish. And so we can go ahead and print this out. Okay. And if we do that and test out a few values, so if x is greater than y, so if I say something like 5, 3, 1, I get true. But what about the opposite? If I say 1, 3, 5, I get false. So I've only detected it going one direction. I know I could detect it going the other direction, by switching the signs, but I actually need to be able to do it in both directions at the same time. So you could try and do this all in one statement if you want to, but I actually, will break this up. Is ordered descending, and then I'm going to make another variable for is ordered ascending, right? where I flip the signs. That's really the only difference here. And what I'm looking for is the case where either they're ordered ascending or they're ordered descending, right? So this is true or this is true. And so what we're really looking for Boolean is ordered, our final answer, is to see whether is ordered ascending is true or is ordered descending is true. So let's think about how this is going to work, right? If the numbers all decrease, right? X is greater than y and y is greater than z, then I know that this will be true, but this will be false. That's okay though, because that means that this will be true. And if the opposite case is true, right? If x is less than y, y is less than z, this will be true and this will be false. If neither one of them is true, so they aren't ordered at all, then both of these will be false and the OR will give me false back. And you can actually try that out, and you should try this out using multiple values here for x, y, and z to make sure that the desired result is produced. So there it was going descending, here it is going ascending, there it gives me true, and now let's give it one that's not ordered at all. It tells me false. Fantastic. I believe that is a good solution for this. I really like breaking this one up into chunks. In fact, that's going to help us out, I think, in the next problem as well. Or, well, maybe not the next problem, but the next problem. Okay. Here we go. The next problem that we're going to look at is called average, but we didn't give you a file. We asked you to create the file for this yourself. So in order to do that, the instructions are given to you here. You're going to right-click on, this is called a package. You can actually think of it very similar to a folder or a directory is what you might, it's a similar idea to that. There are some subtle differences, but none worth worrying about at this particular moment. Then I'm going to go to new. Earlier you heard me say that every piece of code goes in a class. And so we're going to create a new class. Every time I want to create a new program, that means I have to create a new class for that program. So I'm going to create a new class, and I have to give this class a name. We've told you to call this class average. And then I think it's usually important to click this box here. We won't always need to click this box, but for the time being, we're probably going to click this box more often than not. That's going to insert what's called a main method. That's the other part of the, quote-unquote magic words that our Java programs need to run. So click Finish. You can see it's put in a place for us to start writing our code. And now we need to do what the exercise tells us to do. All right. We need to insert the scanner code and have it accept two integers, n1 and n2. Let's take care of that. Now, I know how to type this out, but I wouldn't necessarily expect you all to know how to type that out after having just seen it for a few times. It's totally okay to go back to one of the previous exercises. I think this one makes a lot of sense since it deals with integers, and grab some of the scanner code and copy it and paste it right in here. It's totally fine. It's a totally acceptable thing to do. Okay. There we go. We now want to take those two values and average them together. The average is going to be a double because notice that the values that we type in could have decimals included, even though we asked you to type in two integers, so there's only two integers involved here. The average of those two integers could be a double, so the result needs to be a double. All right, but averaging isn't a terribly difficult thing to do. So I'm going to go ahead and create a double variable here for the average, and I'll just go ahead and add x and y together, and then divide that by 2. I'm going to go ahead and I'm going to try to recreate the example that was right on the instructions there of 5 and 6 to get 5.5 back out for the average. So now I'll go ahead and just print that value out. Let's try it. Let's try 5 and 6 for my values. 5 for x and 6 for y gives me 8. 8 is the answer back. So that's maybe a little surprising perhaps, but let's see if we can work through this and figure out what happened. Definitely got in 5 and 6 for my values of x and y, but this value, this statement here is going to follow order of operations. So, you know, the y divided by 2 is actually going to happen first, and then the addition is going to happen afterwards, which is actually not what I intended. So, with the y being 6, we got 6 divided by 2, which is 3, plus 5, that's where our 8 came from. All right. We can fix that with some parentheses here. That should fix our order of operations problem. Let's try this again. This time I'll type in 5 and 6. And this time I get 5 for an answer. So that's closer to our desired result of 5.5, but it's still not correct. I was expecting to get 5.5 here. So if we try to recreate what's happening, this time I see, all right, x is 5 and y is 6. If I add those together, I get 11, but what's important to note here is not necessarily the value as much as the data type. So x is being used as an integer, y is also being declared as an integer, and when I add two integers together, I'm going to get an integer back out as the result. The 2 that I've listed here is also an integer, so an integer divided by an integer is going to give me an integer back out as a result as well. And because of that, if there's any decimals left over, the computer has to figure out, you know, how to reconcile that with the fact that this should be an integer. So it ends up chopping the decimal off. It doesn't round. You'll notice here it clearly didn't round. If it got 5.5, it would have rounded up to 6 instead of down to 5. So that didn't happen. It does what's called truncation instead. It just chops that decimal off. Everything after the decimal point gets chopped off. So if we think about what's really happening here, the problem is that everything is an integer, and even though I declared this variable as a double, it's kind of too late. Everything that happens on the everything on the right hand side of the equal sign happens first. So by the time I take this value and I compute it and I put it in the double variable, well, it's already an integer, right? It's been an integer and been computed as integers the whole way through. If I want that to change, I need to insert a double earlier into the computation process. There's a couple of different ways that you can do that. I think, you know, the easiest way is to look at this 2 here and turn that into a double, which I can do by putting a 2.0 on the end. So if I run that, here the value for x was 5, the value for y is 6. Now, since this is a double, an integer divided by a double will give me a double back, not an integer, since I don't want to lose that information from the double, and I get the proper solution. The other way that we could accomplish that is by using casting. So anytime I see a data type inside of parentheses like this, that's what's called a cast. It says change the type of whatever comes after this to whatever this type is. So it'll do the stuff inside the parentheses first. It'll add x plus y together, but then it'll take that result and cast it into a double. So my 11 becomes 11.0, and then I divide by 2, which should still get me the correct answer. Let's try it out. There's my value of 5, my value of 6, and I get 5.5 back out for the result. Again, neither of these is necessarily better or worse than the other, just two different ways of solving the same problem that arises due to doing division with integers. It brings up an important question, though, on this that you see here on this checkpoint number 2. Why do we have separate data types for numbers when they're, you know, why do we even bother? Why not just treat everything as a double with decimals? The reason for that has to do with the fact that if I treat everything as a number with decimals, then for all of the cases that I truly don't need the decimals, well, I'm still carrying around that 0.0, right? I have to write that down. I actually have to write that down. That takes up space. It may not be a whole lot of space for one number to store a 2 versus a 2.0, but for a large program that has lots of numbers, that extra space required to carry around that 0.0 for all of those true integers that we know may never be anything other than integers, that's extra space that could add up and slow my program down, or take up room on my computer that doesn't need to be taken up. So if you truly know that something's going to be an integer, if you're counting something, then it's much better to use the data type that fits appropriately. Don't just choose double because you know it'll work for all numbers. That's not the computer science way of doing things. All right, I believe we have one final coding problem to look at here involving checking leap years, right? So we're going to need to make a leap year class just like we did for the average. Let's go ahead and do that first. Remember, I'm going to right-click on the package. I'm going to go to New, Class. I'll type in leap year. And I'll check the box down here to insert the main method, the magic words that we need to get our program up and running. I need the scanner stuff again. I only need to take in one value this time. This time it's going to be a year. So I'm checking to see if a year is a leap year or not. So if I tell you, 2016, which was a leap year, I believe. I don't remember exactly. I was there. But anyway, we'll take a look at the rules in just a second. So I do need the scanner for one integer value. So I'll go ahead and do that. Value for year. Year. All right. So there's a few rules that we need to use when checking to see if something is a leap year. A value is a leap year if it meets the following criteria. So if it's evenly divisible by 4. Part of the prep work we showed you how to check to see if something was evenly divisible or not using an operation called modulus. The modulus operator is the percent sign, and it tells me the remainder after integer division. So if I say something like, let's see here, 7 mod 2, 2 goes into 7 3 times, and then there's a remainder of 1. So the result of this would be 1. That would be the answer here. In this case, we want to see if the year is divisible by 4. So I could say something like Boolean divisible equals year mod 4. So is the year that's been typed in divisible by 4? What did I do? Oh, and then that's actually not enough, right? So if it's that's not divisible by 4. That's modulus of 4. I apologize. That's going to tell me the remainder. So if the remainder is 0, that means that it's evenly divisible by 4. I didn't quite finish my thought there. Notice here too, when checking to see if it's equal to 0, I use a double equal sign. That's how we check to see if equality is happening. Versus a single equal sign, that's used for variable assignment. So this is asking the question, is this value equal to 0? The answer is either going to be yes, true, or no, false, right? Whereas this is saying compute this, and then put that value into this variable. So this will check to see if it's divisible by 4. It is not evenly divisible by 100. So let's check to see, let's write a statement to do that. Okay, so I'm going to amend this. Divisible by 4. Not divisible by 100. So that would be year mod 100 is not equal to 0, right? So it's divisible by 4, and it's not divisible by 100. But then if the rule is divisible by 400, those years are leap years, right? So let's do one to check to see that. There we go. Much like the one for divisible by 4, I just divide by 400 and see if the remainder is 0. All right, so I've got a few Booleans here, and my plan now is to use ands and ors to stitch these together to see if the year is a leap year or not. That's the idea. So I'm probably going to create one more Boolean variable. So let's reason about this, right? We know some examples to try. 1900, so 2020 is a leap year. 2000 is a leap year because it's divisible by 4 and 100, but also divisible by 400. So that's a little tricky thing that we'll have to pay attention to. Okay. So I'll create one more Boolean, is leap year. And I know that it'll work if it's divisible by 4. Oops. Can't spell all of a sudden. And not divisible by 100. I've been misspelling divisible this whole time. Look at me. Too many I's in that word. All right. I think this will actually work for most of the situations. Let's print it out and try out a few values here and see how far we've gotten. So we haven't used this variable yet. Eclipse is even telling us, hey, you made this variable, you never used it. So we aren't gonna, it's not gonna work for all situations, but let's try a few of them and see. I know that 2020 is a leap year, okay. 2021 is definitely not a leap year, right? All right, so what's another example? The year 1900 is evenly divisible by 4, but since it's also evenly divisible by 100, it's not a leap year. So let's check 1900. It's not a leap year, right? It's not a leap year. But then 2000, because it is divisible by 400, is supposed to be a leap year, right? And right now it's telling me that it's not a leap year. So we need to account for that. Basically, if it's divisible by 400, we don't need to worry about these two at all. We don't even need to check those. So if it's divisible by 400, we can stop. We know it's a leap year. Or, if it's not divisible by 400, then we have to look at these. I'm going to use some parentheses to kind of wrap this statement. And then I'm going to put an or in front of it and put my other variable. Out front. All right, now let's think about what happens. If it's divisible by 400, I know this is true, and then it honestly doesn't matter what comes after this. Remember the or statement, the way that works. If either the left or the right side is true, then it's going to give me a true statement back. So that's okay. Otherwise, if it's not divisible by 400, we still have to check, right? We can still check these other values to see if it's divisible by 4 and not divisible by 100, in which case it could still be a leap year. Let's try this again with a few more values to test some things out. 2020, still a leap year. 2021, or 2022 even. 2023, not a leap year. 1900 is not a leap year because it's divisible by 100, but then 2000 is, right? Because it's divisible by 400. I believe this is a workable solution. Again, not the only solution by any means. I know that people have probably come up with alternative ways to solve this problem. So, if you found a different solution, then great. I think that's fantastic. But yes, this is definitely one way to go about it. Okay, I think that's all of the studio coding problems. There were some problems down here at the end that ask you to choose some appropriate data types. So I'm not going to go through those. I hope that you talked to your group mates about those and had some conversations about what data types are appropriate for different kinds of data. But one thing that I wanted to talk about briefly before I wrap up this video is assignment 1. So this is our first homework assignment for the semester, and we're asking you to compute a grade calculator. So first thing you'll need to do is create a repository. Unlike the studio, you're on your own here, right? So you can definitely refer to the studio code, use it as much as is useful to you. On the assignment, that's what it's for. So don't feel bad about using that code or any of the code from the exercises, things like that. But the assignment itself is an individual assignment. You're expected to complete it on your own. So you're going to go ahead and make the repository. You're going to make a class to make a grade calculator, just like I did a couple of times as part of the studio. And then you're going to ask the user to type in some information. So you're going to create your scanner class and then ask the user to type in the information that you need to represent the various parts of this course. So we ask you to create 7 variables. We ask the user to type in 7 different things I'm going to reinforce that a few different times because inevitably somebody asks for a lot more than that. So they ask for every single assignment grade and every single studio grade. That's not necessary. There's only 7 things that you need to ask for, the 7 things that are on this chart. For the assignments, I'm not asking you to type in the grade for every single assignment in the class. That would take a long time. Instead, I'm asking you to type in one number that represents the average assignment grade. Okay, so the average for all of the assignments in the class as a value between 0 and 100. So take a look at the chart. Be very sure you understand what's being asked of you here. Don't do any extra work. Don't do any work that's not being requested of you. Don't make it harder than it needs to be. Definitely ask questions. Get help from a TA if you need it. I provided an example down here of what it might look like once you're done. So you need to actually, after you accept these values, compute the grade for this person. See what grade they're going to get in the class. This class, like the exact class, the 131 class that you're taking right now. So you're going to need to refer to the course policies page to see how much all of these individual components are weighted. That's also a good thing for you to know as well. And then you're going to have to compute each of these components and then sum up the total grade. One final thing that I want to talk about in regards to this assignment, you should definitely, of course, read the entire specification. I'm not going to cover the whole thing. But one final thing that I did want to talk about is this idea that you'll need to do some rounding. So you'll notice that on the output here, all of the values are rounded to 2 decimal places. So any extra decimal places that come after that have been taken off. And we ask you to do that using something called math.round. So while we may have not introduced you to math.round specifically in the prep work or the studio, we did introduce you to other parts of the math library. And rounding is not a particularly complicated process. You can see that Eclipse is telling us it's going to round this value to the closest long, so the closest integer, right? So if I give you 7.5, that's going to round it to 7. If I give you, 25.6329, it's going to round it to 26, right? It's not going to look at any value past the first value. So you might be asking yourself, okay, well, you asked us to round 2 places after the decimal point. How can we do that if this is just going to round to the nearest integer value? Consider that, there are ways to use arithmetic to move the decimal place to the left, to move the decimal place to the right. You may have to do that in order to accomplish this task. So that's a big hint that I'm going to give to you for this problem in particular. But if you have other, if you're still stuck on this, you still are having problems with how to round or other things related to this assignment or the exercises or the studio or anything related to this class, I again would like to remind you that there are many ways that you can get help. So starting this Sunday, we've got our TA office hours. I just posted the room on Canvas here earlier today. So if you click the office hours link on Canvas, you'll now see that office hours are going to be in the Erbauer 222 computer lab Sunday through Thursday from 6 p.m. to 10 p.m. So you can go there to get help. You can go there to demo assignments, turn things in if you want to. You can also do that on Tuesdays in class during class time. You can also do that by coming into my office. So if you come to the office hours page, there's a link here that you can click to schedule an appointment to come in and see me. I keep this up to date with my schedule, so you can see that there are days on here. I don't know why there aren't more days than that, honestly. I feel like there should be... I'm going to go take a look at that and see why I don't have more days available on my schedule, because I feel like I definitely should. Do people really book that much time? Wow. Anyhow, yeah, you can definitely come book a time to come and see me whenever you'd like. I'd be happy to demo assignments, talk to you about homework assignments, or anything related to the class for that matter. So don't be afraid to use that link if you need to. Trying to think of what else. I feel like there was one other thing I needed to say, but I couldn't remember. Oh yes, Piazza. That's the final way that you can get help. So if it's outside of office hours, You can always go on to Piazza and make a post on there. People have already been using this tool. I've been using this tool to make announcements. So please go create a Piazza account if you've not already done so. And if you run into questions on homework assignments, things like that, then you're also welcome to post about those on Piazza. The TAs are on there. I'm on there. So it's a great place to get help. All right. That's going to do it for the studio review for this week. I hope you all have a great weekend, and I will hopefully see you all back on campus next week.